Hello students, myself Anna Sahib Gorane from XI.SCI's RBNB College Srirampur. I am a junior college teacher in physics. Now today we study topic from 11th science, that is the optics. Now what is optics? Optics is a science of light. You know light, you know about the light. Light is a form of energy. It is a form of energy. Objects are visible to us due to light. Due to light, we can see the world, colorful world, with the help of our eyes due to light. It is a transverse electromagnetic wave. Transverse electromagnetic wave whose speed is very high. In vacuum, the speed is about 3 into 10 raised to 8 meter per second. The speed of the light is very high in vacuum. It travels in straight line in a given medium. This property is also called as rectilinear propagation of light, and shadows are formed due to the rectilinear propagation of light. Because light travels in straight line, shadows are formed, and the property of light that it travels in straight line is a rectilinear propagation of light. Now we see what is the ray of light. Ray of light. Line which represents the direction of propagation of light is a ray of light. The line which represents the direction of propagation of light is, we call it as ray of light. And then another concept is a beam of light. Beam of light is nothing but bundle of rays of light in a particular direction. We call it as a beam of light. Then we see the nature of light. Light behaves dual nature. Dual nature. Dual means two types of nature. It behaves as a wave as well as it behaves as a particle. In some phenomenon, we see the wave nature of light. In some phenomenon, we see the particle nature of light. So nature of light is dual nature. That is, it is a wave nature as well as particle nature. And some common observed phenomenon of light can be classified into three categories. In our life, we see some common observed phenomenon of light, and they are classified into three types. First is ray optics. Or we also call it as geometrical optics. The second one is wave optics. It is also called as physical optics. And third is particle nature of light. we classify the natural phenomenon which are observed in these three categories. In ray optics, we study reflection of light, refraction of light. You know this phenomenon, reflection, refraction, double refraction, and total internal reflection. In this type, we study this phenomenon, ray optics or geometrical optics, reflection, refraction, double refraction, and total internal reflection. In wave optics or physical optics, we study or we can explain the phenomenon of light related to wave. It explains interference of the light, interference phenomenon, then diffraction, that is the bending of light around the corners of the obstacle is the diffraction, polarization, and Doppler effect. Using the wave optics or physical optics, this phenomenon of light can be explained. Some phenomena related with light are associated with the particle nature of light, such as photoelectric effect. This particle nature explains photoelectric effect. Then emission of spectral line, Compton effect, these phenomenon of light are related with particle nature of light. In ray optics, these are the phenomenon. In wave optics, this phenomenon we can explain. In particle nature, we explain this phenomenon. And also, in ray optics, we study the image formation by mirror and lenses. Now in optics, some Cartesian sign convention is used, that is, which distance is positive, which distance is considered as negative. This Cartesian sign convention you already know, but just I will explain in short what is this sign convention in optics. Cartesian sign convention. Here, this is the x-axis. It is considered as principal axis and this vertical axis. And this origin is considered as pole of mirror or lens. Now in this sign convention, all distances are measured from this optical center or pole. The origin of that x-axis is considered as a pole or it is the optical center. The figure should be drawn in such a way that incident rays travel from left to right. The incident rays travel from left to right. The x-axis is chosen as the principal axis with origin at the pole. Distances measured left to the pole are negative and right to the pole are considered as positive. Same as the Cartesian axis, x-axis, y-axis. Above the principal axis, the distances are considered as positive, and below principal axis, the distances are negative. these distances are positive, these distances are negative. Towards the left, the distances are negative. Towards the right, the distances are positive. So it is a Cartesian sign convention. As you know, x-axis, towards the right of the origin it is positive, towards the left it is negative, upward from the axis positive, downward from the axis negative. But here one main thing is the distances are measured from the optical center of the lens or mirror. We call it as a pole. The ray optics, in which we study the formation of image by mirror and lenses, is based on some fundamental laws. The ray optics is based on some fundamental laws. Fundamental laws in ray optics. You know these laws. You studied these laws in previous standards. But I just revise these concepts. First is light travels in straight line. Light travels in straight line in homogeneous and isotropic medium. See this two important word, homogeneous, isotropic. You know light travels in a straight line. Homogeneous medium means properties of medium are same everywhere in the medium. And isotropic means the properties of medium are same in all directions. So this is the one basic fundamental law in ray optics. Second important law is when two or more waves intersect, when two or more light waves intersect each other, two or more light waves intersect at each other at a point without affecting their path, they travel beyond that point. Two or more light waves intersect at a point, then without affecting their path beyond that point, they move without affecting their path, without affecting its path beyond that point. What it means? Suppose this is a ray of light traveling along this direction. Suppose again this is another ray of light. They intersect at the point, but they travel affecting their path. Their path is not affected even if they intersect. So this is the second fundamental law in ray optics. The next one is about the reflection of the light. Third one is about the reflection of the light. We know laws of reflection. The bouncing back of light from the surface is a reflection. Suppose this is the reflecting surface. We draw here normal, that is the perpendicular to the surface. This is the normal. This is the incident light, incident ray. The ray is bouncing back. This is the reflected ray, incident ray. This is reflected ray. Angle made by the incident ray with the normal is angle of incidence, we know. Angle made by the reflected ray with the normal is angle of reflection, that is R. And one basic law here is angle of incidence is equal to angle of reflection. In case of reflection, these two angles are equal. Then incident ray, reflected ray and normal at the point of incidence, suppose point of incidence is O, they all lies in the same plane. Incident ray, reflected ray and normal at the point of incidence, they all lies in the same plane. So this is about the laws of reflection. Then we see the laws of refraction. Refraction. The change in the direction of light when it passes from one transparent medium to other, we call it as a refraction. And for the refraction, the refracting surface is there like glass or water. Suppose this is the refracting surface. We draw here normal at the point, suppose O. This is the incident ray. This one is the normal. Incident ray, this is medium 1. Suppose this medium 1 is air, medium 2 is glass, that is the denser medium. When it travels from one medium to other, it changes the direction. This is the refracted ray. This is the point of incidence. This phenomenon we call it as a refraction. The incident ray and refracted ray are on opposite sides of the normal at the point of incidence. Incident ray, refracted ray, they are on opposite sides of the normal at the point of incidence, and they all lie in the same plane. The next important law is, if theta 1 is angle of incidence in medium of refractive index N1, suppose refractive index of this medium is N1, if theta 2 is angle of refraction in a medium of refractive index N2, then they are related by the Snell's law. And that Snell's law of refraction is N1 sine theta 1 is equal to N2 sine theta 2, where theta 1 is angle of incidence in medium having refractive index N1, theta 2 is angle of refraction in a medium having refractive index N2. And the relation between these is given by the Snell's law of refraction. So this is about the fundamental laws we use in ray optics. Then one another concept is, we see the reflection of the light and how many images are formed if mirrors are inclined to each other at some angle. Reflection. You know this basic concept, that is the reflection of light. Reflection. Bouncing back of light from the surface, we call it as a reflection, and we also know the laws of reflection, that is angle of incidence is equal to angle of reflection. Incident ray, reflected ray and normal at the point of incidence all lies in the same plane. Now we see reflection from plane surface, like mirror. Reflection from plane surface. Mirror reflects the light. The image of an object if this object is placed in front of plane reflecting surface, like mirror. We see what is the nature of the image. If the object is placed in front of plane reflecting surface, the image is virtual and it is laterally inverted. Image is not real. Image is virtual and it is laterally inverted. Now see what is laterally inverted. Suppose this is a mirror. If this is the object, the image is behind the mirror and it is laterally inverted. It means like this. This is laterally inverted. Image is virtual, it is laterally inverted. Then second is same size that of the object, having the same size as that of object. This is just inverted, laterally inverted, same size as that of the object, situated at the same distance. This distance is same. Situated at same distance. Situated at the same distance as that of the object, but on the other side of reflecting surface. So this is the image of the object in front of plane reflecting surface, like a mirror. The image is virtual, it is just inverted, laterally inverted, same size as that of the object. The size is same, that of the object. And another main thing is, it is situated at the same distance as that of the object, but on other side of a reflecting surface. This is the main part. Now we see another interesting concept here. If two plane mirrors are inclined to each other at some angle, that is, there is some angle between the mirrors. Suppose this is one mirror, this is the polished surface of the mirror, coated surface, and this one is the reflecting surface, and this is the another mirror. If these two plane mirrors are inclined to each other at some angle, suppose angle between the mirrors is theta, and if object is placed between the mirrors inclined to each other at some angle, multiple images are formed, that is, the number of images are formed due to multiple reflections of the mirrors. Multiple reflections from both the mirrors. If object is placed in between these two mirrors, if single mirror is there, we can see a single image. But interesting phenomenon is, if two mirrors are there and they are inclined to each other, and if object is placed in between these two, we see the multiple images or number of images This is due to the multiple reflections from both the mirrors. The number of images formed depends on angle between the mirrors. It depends on angle between the mirrors. And second one main thing is it also depends on position of object. How many images are formed, that depends on these two factors. That is the angle between the mirrors and position of the object. This is the angle bisector of the mirror. Suppose this is the angle bisector. This line divides this angle into two equal parts. It depends on the position of the object, whether that object is on this angle bisector or anywhere in between two. This factor is very important, and we can calculate this number of images by using one formula. If suppose this small n is 360 upon theta. Theta is the angle between the two mirrors, and suppose small n is 360 upon theta, and suppose capital N is the number of images formed. Number of images. We denote capital N for the number of images, and this N depends on this angle between the mirrors. And one another factor is position of the object, whether it is on the angle bisector or not, or it is on anywhere. First point is, if this is this 360 upon theta, if this small n is even integer, if this n is even integer, that is 2, 4, 6 like this. If 360 upon theta is a even integer. If it is even integer, the number of images will be this n minus 1 for any position of object. Any position of object. That is, object may be on angle bisector or anywhere in between the images, mirrors. If this n is even, that is 2, 4, 6 number of images will be that n minus 1 for any position of object. For example, if theta is 90 degree, angle between the mirrors is 90 degree, then this small n will be 360 upon 90, that is 4. 4 is a even integer. Then number of images will be 4 minus 1, that is 3. Object may be anywhere if the n is even integer. Very simple. Then second point is, if n is odd integer, if n is odd integer, that is 1, 3, 5, 7 like this, then number of images will be like this n minus 1 if object is on angle bisector. Object is on angle bisector. Of the mirror. For the even integer, if the object is exactly placed on the angle bisector, means here For the even, if n is the odd integer, number of images will be same as this, that is the n minus 1. If object is exactly placed on the angle bisector of the mirror, and the images will be same as n if object is placed off the angle bisector. If object is placed off the angle bisector. Of the angle bisector means it is not on the angle bisector. It may be anywhere than this point, angle bisector. So for odd integer there are the two cases. If integer is odd and if object is on the exactly placed on the angle bisector, the number of images will be n minus 1. And if object is not on angle bisector, we call it as of the angle bisector, the number of images will be n. For example, if theta is 120 degree, small n will be 360 upon 120, that is 3. 3 is an odd integer. If object is on angle bisector, the number of images will be 3 minus 1. If object is on the angle bisector, number of images will be 3 minus 1, that is the 2. And if object is placed off the angle bisector, the number of images will be same as this small n, that is the 3. Very simple part. So this is if n is integer. It may be odd integer or even integer. For even integer there is no problem. Number of images will be always n minus 1, small n minus 1 for any position of the object. For the odd integer it is same as n minus 1, but the condition is object is on the angle bisector. And if object is not of the angle bisector, that is it is not on the angle bisector, number of images will be same as n. Then our third important point is, if n is not integer, if this n is equal to 360 upon theta is not integer, if this n is not integer, if this n is not integer, then number of images n is equal to m. If n is not integer, number of images capital N is equal to m, where m is integral part of n, where this small m is integral part of n. Just I will explain this in detail. If angle between the two mirrors is 50 degree, then small n is, by using this formula, small n is 360 upon 50. This is 7.2. This 7.2 is not an integer. This is n. Then number of images will be m. What is m? M is integral part of this n. This is m. This is the integral part. In this 7.2, this 7 is the integral part, 2 is the decimal part, after the decimal point. If n is not integer, then this number of images will be small m. M is the integral part of that n. And for example, if theta is angle between the mirrors is 50 degree, small n will be 360 upon 50, that is the 7.2. 7.2 is not an integer. Number of images will be integral part. This is the integral part. We call it as m. and hence here the number of images will be 7. So this is about the reflection from the plane surface, and the number of images formed when the two plane mirrors are inclined to each other, that depends on the angle between the mirrors and position of the object. Okay students, today we stop here. Thank you.